All right, I'll finish. First one is the fifth root. So we did one like this yesterday, but 1/5 power is the same as the fifth root. The denominator becomes the index. So I use the fifth power to cancel it out. What type of equation did I end up with when I canceled out the radical? Linear, yeah. And I ended up solving and getting 11. Why did I not check for extremes? You had an odd index. You can check. You can check any by plugging in. If you get something wrong, it's not because it's extraneous in this case. I don't make mistakes. And then on this last one, a 1/2 power is the same as a square root, so I canceled it out with a square. In both cases, the radicals were already isolated, so I was able to already remove them. What type of equation did I end up with? Quadratic. And we have multiple methods for solving quadratics. What method did I appear to choose? Factoring. I chose to factor, and I ended up with two solutions. But those two solutions were for this quadratic equation. So I tested each one out. How many worked out? Just one. So what ended up being the only solution to this radical equation? You have something different on your paper than I have on my screen. Now is the time to speak. All right, let's do the two on the left side of the screen here. Let's start. Not as much as the last time. Before you get too much into it, let me point something out that some kids got maybe a little bit confused with. Because we did one just like this yesterday, but the difference is what was on the other side. Yesterday we had an actual constant on the other side. Like what's on the right side of this first one here? Nothing. There's nothing there. So here first step we do is to add these two x. What am I trying to accomplish here? Yeah, I'm trying to isolate a radical. Did I accomplish that? Yeah, and not only did I accomplish it, I accomplished it twofold. How many radicals here are isolated? They both are, yeah. If I would have had a constant on the other side like I did yesterday, I could only do one at a time, and which was the one I suggested that you try to isolate. Yeah, I will isolate the one with the both terms, but in this case it was irrelevant because I can isolate both. Okay, you can continue now. if you are working ahead, you should have gotten 6 like I do. But something interesting happens here. I'm going to checking for extraneous because it's an even index. Whoa, Mr. Romero, it didn't work out. I know I'm supposed to get 0, but I didn't get 0. So it must be extraneous, right? Any thoughts? No, I don't know. The solution's either going to be 6 or it's going to be no solution. I want some guidance from you. Instead of me telling you what to do, I want to see that you're actually thinking critically and applying. What? I'm trying to say, you said what you said? Well, what did you see at school? What did we spend the first 2 days of this week doing?
Or like
Yeah, like the first 2 days of this week, went over stuff that's not even doing a quiz. But I did that to try to apply a foundation so that, whether it be review, whether it be seeing it for the first time, so you had some idea how to work with radicals. When you're checking, we're not solving, I'm not isolating a variable here, I'm not trying to cancel anything out, but I'm trying to simplify. And in this case, simplifying calls for subtraction. And I need to subtract these two radicals and see if I get 0. Yes, nowadays with the calculators, you can put that in the calculator, you're going to see that you're going to get 0. Or you can realize, hey, that 54 though can be simplified. I can put it into a tree. And I can pull out a 3, and we're going to look at that. What stays on the inside? 6. So what's anything minus itself? I do end up with 0 equals 0, so all the children rejoice. With 6. And I think I gave you enough of a head start also to finish the other one, so at least here we have an odd index. And notice that we already have both radicals isolated also. Even though there's a 2 on the outside, it shouldn't be an issue, but it scares me to think that it might be an issue as well. We would hopefully remember, like we're going to know to cancel out the radical and have the x minus 1. We hopefully remember that there is a number on the outside, so we put the parentheses. But what scares me is what number you're going to put on the outside. I think too many people would put a 2. What number should be out there? Now it becomes an 8. Right, to check for extraneous. So yeah, so some of these slides here were borrowed, and some of these were my own. This is one of the borrowed ones. I've never used this, so and this thing says it takes 7 minutes to do. So let's see if we can do that. I'm not gonna wait the entire 7 minutes before I start, but see if we can do those 7 minutes. It's this hash brown 7-minute challenge. All right. Well, go ahead. I'll let you finish. I'll let you finish the full 7 minutes. And then we'll read. Keisha, you finished already?
I don't know.
I'm partial to the plain ones. But then now they've got that, but hey, you know what's implemented a peanut butter? They got the crispy ones. And now they got those caramel ones. It looks like a teeth. It's called cashew living. I told them to too. They taste a little bit like a crispy ones. All right, so on the first one, the solution you should have gotten was 6. Got something different, you let me know. Why did I check this one for extraneous? The index is even there, but when I plugged in that 6, I ended up with 6 equals 6. So 2 equals 7 means it was a valid solution. The next one is probably the most interesting one we'll do today. Not only because, like, the solving part shouldn't have been too bad. Make sure that you end up with a 25 here in front. You square that 5. You square the 5. Good. And then once you solve, actually, here's another question. What type of equation did I end up with there after squaring? Linear, good. And then you should have ended up with 13 over 12. If you didn't get 13 over 12, say something. But Mr. Romero, you don't like fractions. Yeah, it definitely makes the second part more challenging. If you want to just go ahead and convert the decimals for the checking part, that's fine. But be careful, don't round. Like for instance, if that would have been the other way around, 12 over, put 12 over 13 in the calculator. Let's say the same would have been backwards. Yeah, you would have, it's a huge decimal, so you can't do the decimal thing. But 13 over 12 you can. What's 13 over 12?
1.78.
Or repeats?
Yeah.
Oh, then I take it back, and you can't do it. JK on the wall. So anyway, some people might get confused. Whoa, hey, where'd you get this 12 over 12 from? It's 1. There's ones here. But I write it as 12 over 12, so I have a common denominator. And look, so what are we doing when we're checking? Okay, I asked you yesterday, what are we doing when we're solving? When you're solving, what are you doing? You're isolating. But when we're checking, we're not solving. So what are we doing? I think seeing is a verb, but no, we're not seeing. We always see.
So.
No, we're not solving. Well, you substitute the first step, but once you substitute, we're simplifying. Okay? But I mean, even further than that, we're simplifying for the purpose of comparing. All we need to do is compare. We want to see if we end up with 2 equal sides. So as I continue to simplify, I hit this little kerfuffle here where, geez, well, what can I do with the square root of 1 over 12? Well, I know that square roots are distributable over division. What's the square root of 1? 1. So I went ahead and did that, and I multiplied that 1 times the 5. So I got 5 over square root of 12. Is that in simplest form? No. I'm not supposed to have a radical on the bottom. Who cares? Like, I'm not really trying to get in simplest form. I just need to compare. I need to see if both sides are the same. Come over to the other side. I distributed the square root. What's the square root of 25? 5. And I put that same square root in the bottom, and that was enough for me to confirm that indeed, yes, both sides are the same. I ended up with 2 equal sides. So what's my solution there? 5 over square root of 12?
Yeah.
13 over 12. And then on the last two, those are, if you want to say, the easier ones, because they're both odd indexes. You do not need to check for extraneous. I got 7 over 3, then I got 10. If you got something different, holla. You sure you got the same things? If you want to sleep, I can put you somewhere more cozy. Have a little nook. I won't be all busy around you. No questions. All right, and then the main thing for today were these guys. I took this from a those packets that all the teachers use. They're not my favorite, but you guys won't mind because they're not my favorite. I wish they were a little more challenging, but whatever. It does the trick. And yes, there will be at least one word problem on El Quizzo and El Testo next week. Who likes word problems? I know that also a lot of us don't also just like math overall, but specifically when it comes to word problems, I feel that the reason why we don't like word problems isn't so much the math part of it. It's the reading part, it's the translation part. How do you turn words into math? That process is known as modeling. When they give you a passage and you have to either come out with an expression, an equation, a function, something out of that on your own, that's called modeling. But on every single one that we're going to do here, and the one that you may or may not have on the quiz, it's going to be modeled for you. Look at this first one here. They give you the formula. They say S is equal to the square root of 30f. But now we have to read to see what these mean. So it says the speed, S in miles per hour. S is the speed. That a car is traveling when it goes into a skid can be estimated by using that formula that we just wrote. F is the coefficient of friction, and D is the length of the skid marks in feet. After an accident, a driver claims to have been traveling the speed limit of 45 miles per hour. The coefficient of friction under the accident condition was 0.7. Is the driver telling the truth about his speed? So we're looking for his speed. That's what the question is asking. So what's my variable going to be? We're looking for speed. What's my variable going to be? Yes, Julian.
That's good. What's it?
What's a skid?
Yes.
Like those marks, like the tire marks?
Oh, okay.
Yeah, S, we're going to be looking for S. And a formula is like a fancy word for an equation that has more than one type of variable. So if you're given a formula and you need to solve for one of the variables, you have to be given the other ones, or at least given enough information to find the other ones. If I want to solve for S, I need to know F and D. This one is probably the easiest of the bunch that we're going to do because the variable that we're looking for has already been isolated. So there's no solving involved here. This is just going to be substituting and simplifying. What can I put in for the friction coefficient? 0.7. Wait, but Mr. Romero, I'm looking for that D, the distance of the skid, but I don't see it anywhere. Yeah, look at the picture. It's on the picture. I guess this would be more like a standardized test thing, but be careful on these with units. Sometimes they'll mess around with units. like the formula will need the distance to be in miles, but then they give you the diagram in feet. So just be careful. But all the units work out here. You know, they wanted this in feet, they're giving it to you in feet. So now just put this in the calculator. Square root of what is 30 times 0.7 times 120? Is it exact or is it a decimal? It should be exact. So what is it, 2,000? 520? I don't know if that's a perfect square. Let's like round. Okay, so we're gonna have to round it. 50.2? All right, so what does this mean? We were looking for a speed. We got 50.2. Speed in this formula was being measured in miles per hour. So this person was traveling at a rate of approximately 50 miles per hour. So let's go back to the question. Is the driver telling the truth about his speed? He said he was going the speed limit. What was the speed limit? Yeah. So the answer to this would just be no. And it has to explain he was going 5 miles per hour over. How I know he was going 5 miles per hour over? Yes, exactly. Any questions there? Okay. The formula S equals square root of 21D relates a stunt car's speed in miles per hour at the beginning of a skid. Hey, is another skid word. Not Squidward, but skid word. To the length of the skidded feet. A stunt driver must, and by the way, look, they've already modeled for you, so you're not having to come up with that formula. It's being given to you. That makes things substantially easier. A stunt driver must skid her car to a stop just in front of a wall. When the driver starts her skid, she is traveling 64 miles per hour. When the driver comes to a stop, let's look at the question, because this is going to tell us what to look for. How many feet will be between her and the wall? So if S is speed and D is the length of a skid, we're looking for a distance. Okay? So we need to know how long her skid is. I realize that it's asking you how far she's going to be from the wall, but we can deal with that later. What we don't know is how long the skid is going to be. How fast was she traveling? So 64 is equal to square root of 21. What should I do first? I should square both sides. 64 squared is 49.6. And then divide by 21. And then tell us to round here. It's round to the nearest foot. All right, so what is 4096 divided by 21 to the nearest foot? 195. So 195 is approximately the distance of the skid. Well, but they want to know how far away she was from the wall. When she began to skid, how far away was she from the wall?
200 feet.
At the start of the skid, she was 200 feet away. So when she stops skidding,
5.
yeah, how'd you get that?
200 minus.
You subtract, so she ends up 5 feet from. See, you want to get stuck in? You don't know yet. Going too fast, stop me. Caroline, too fast. You finished these already? The diameter D in inches of a rope that is needed to lift a weight that is W tons. So W is the weight, D is how thick the rope has to be. It's given by that. See, they already modeled for you. Look at the question. How much weight? So what do we need to solve for? What do we need to solve for? W. They solve for W. You want to solve for W, they have to give me D. And they do give me D, it's 1.5. So 1.5 is equal to square root of W over. Hey, pi, I haven't seen you in a while, pi. What do I do first? Solve for W. Very good. Times pi is good. I hope, I know teachers do it differently, so I hope your teacher taught you that when the problems that involve pi, don't round early. I know pi is irrational. Please don't put 3.14. This is a word problem. It will more than likely involve rounding, but let's leave the rounding to the end. What right now we are trying to solve. When we are trying to solve, what is our primary objective? What are we trying to do when we're solving for the second time today? Isolate. So let's worry about the isolating part first. Let's treat pi as a variable. So I'll just write 1.5 pi. I know pi is not a variable, but let's just treat it like a variable, like a symbol. What should I do next? Square it. Square both sides. The left side will be 2.25 pi squared. This side is just 15. And then that is the last divide by 15. What were we looking for? What are we solving for? We're solving for a weight. And if somebody asks you how much something weighs, you're not going to say it weighs 2.25 pi squared over 15 tons. It makes sense. But at the very least, what I've done is now isolate. Now I can round. Let's use our calculator skills. I would do 2.25 pi squared, hit equals, and then divide by 15. I don't see where this tells us where to round, so. The weight, approximately 1.3. So 1.48. Can you read this stuff on the printout or just? Yeah, I'm like, no other question on that one? Okay, more geometry. The length of the diagonal of a rectangular prism is given by this formula. They've already modeled it for you. And they tell you that L is the length, W is the width, H is the height, and D is the diagonal. What is the height of the prism shown? So if we are to use this formula to find height, they have to give me the other three. Of those three, the only one that has to be exact, like you have to put in the right spot, is the D, the diagonal. Which one of those numbers has to be the diagonal? The 18. Other than that, the 13 and the 5 are interchangeable. So let's say 18 is square root of length. It doesn't matter. I'll put 13 squared plus 5 squared plus h squared. And now let's solve this one. Tells me to round to the 10th. So 18 equals to 169 plus 25 plus h squared. 18 is equal to square root of 94 plus h squared. What do I do next? Square both sides. And 324. Isha got 130, so that's good. And this hits around to the nearest tenth. So what is the square root of 130 to the nearest tenth? What? 11.4. And what's the unit? Centimeters, yeah, no diagram. But wait, there's more. What if? This is nice because it shows me to learn something. Like, to answer this question, we don't have to do anything. I will do it to show you, but we actually don't even have to do anything. Suppose the length, the width, and the height are all doubled. What effect would that have on the diagonal? We'll learn something in geometry next year. If I get the measurement I just found, that one, and I double all of them, what would happen to the diagonal? Geometry. Quadruple? Guess. Last period I had one student who seemed to really go to lose this.
Would it be triple?
Yes, I'll give you that, yes, it will increase, but by how much? By what factor? I don't know if you guessed it, but yeah, it's also gonna double. Yeah, that's why I said, yeah, I don't know if you guessed it or not, but yes, that is correct. You want to explain how you do it? Yeah, I didn't think so. The reason why it also doubles is the type of measurement. You should have learned last year about dimension. One-dimensional measurements, two-dimensional measurements, three-dimensional. Like, what is a one-dimensional measurement?
Just X and Y. I mean, just.
Measurements. Which are types of? Types of? Say length or distance. Distance, length, which are all that, those are one-dimensional measurements. What is a two-dimensional measurement? Not a two-dimensional measurement, not a distance. Area, very good. Now, in this case, you're probably talking about surface area, but yes, any type of area is two-dimensional, which is why the units at the end say square feet, square inches, square yards. What is a three-dimensional measurement? Volume, right? So what you should have learned is, if you get the one-dimensional measurements, which all of those, length, width, height, those are all one-dimensional, and then it takes you in all three dimensions, like it takes you like horizontal, vertical, and depth, and you double all of them, then any other one-dimensional measurement that's there, whether it be like the perimeter of a face, any other distance would also double. It increased by the same factor. And this diagonal is a distance, so it's also going to double. If I were to ask you what would happen to the area, in this case the surface area on the outside of that prism, what would happen? How much bigger is it going to be? Remember, the one-dimensional measurements are getting 2 times bigger. So what would happen to the two-dimensional measurements? It's going to get 4 times bigger. What would happen to the 3? What would happen to the volume? Huh? It would get. Anyway, but let's prove it. They were asking about the diagonal, right? So I don't like rounding. I don't like rounding at all. I especially don't like rounding before I'm done. But one of our dimensions, this height, is rounded. So I could go back to where I came from and use the square root of 130, but then I'm going to be putting the square root of inside of a square root, and I'm going to confuse you. So just for the purposes of this, let's use that rounded number, but we're talking about doubling it. So what's double 11.4? It is 22.8. And we square that. Plus, the width was, let's just say it was 5. So 10 and you square it, and the length is 13. So somebody put all that in a calculator. It might not be exact. because of the fact that the 22.8 was rounded. Put all that in the calculator and tell me what you get. I'll help you out. You should be getting 36. That's okay. It might not be exactly 36 because of the fact that something that's rounded, but like the exact amount should be 36. Now you get exactly 36. I'm giving you a second if you want to try to put something into your calculator to see if you know how to use it. I would put it in the calculator by doing 22.8 squared plus 10 squared plus 26 squared. I would hit equals, and then I take the square root of that number. What did you get, Hannah? Did you get 36? Bad traits are going on. Okay, good. That's it. Last one. The time t in seconds for a pendulum to complete one back and forth swing is given by this formula, where L is the length of the pendulum in meters. So L is a length and T is the time. But again, they've already modeled it for you. You're not having to take care of the modeling. On the test and quiz, on the work problem you get, you won't have to worry about modeling. But you will potentially have to worry about solving. So here they want us to find the length. If they want us to find the length, what do they have to give us? They have to give us the time, and they do say that one back and forth swing is 2.2 seconds. So let's substitute like they do in the hood. 2.5. That's the first step for solving for L. I want to isolate, but what should I do first? There is, I'll tell you this, there is more than one thing I can do first. Yeah. Oh, wait, whoa. Mr. Roman. Yesterday, when we were dividing, you said that if we can't divide what's on the other side, that we shouldn't divide. We should just remove the radical there. And in most cases, that I would agree with that. The thing is, this is a word problem. This is probably going to involve estimation. So, I'm not going to round now, but I don't have to round anyways. So, I might as well just start figuring stuff out of that right second. Juancito. You're almost there, man. What do you have next period? Is that more fun than math? It's weird. 2.2 divided by 2 is 1.1. Over pi, I can do that. You don't have to, but you can. And then, what's the next step? Now I would square both sides. I'm trying to get rid of that radical. You don't have to do this, but I know 1.1 squared is 1.21. And on the bottom, I gotta square the pi also. If I'm allowed to distribute that exponent to both numbers. Then on this side, I just have L over 9.8. What's the last step to solve for the length? You could do a proportion. You could. I don't think you need to though.
Cross multiply.
No, well, yeah, you could, but you don't have to. I would just multiply by 9.8. If that L was on the bottom for some reason, yeah, I definitely do a proportion. But when the L is in the numerator, just multiply by 9.8. So, can somebody use their fancy calculator to tell me what is 9.8 times 1.21 divided by pi squared? And then say what around the nearest 100. The nearest 100 to it. Yeah, Julian, you got it? Calculator at home?
No, that's good.
They keeping it?
Yes.
I think one was keeping it. We saw that calculator that must have it. I think that's keeping it. No need to use that calculator in here. Carolyn, you got something? What'd you get?
1.2.
You didn't get it. Hannah got that. Yeah, so she's sneaky. She's a sneaky one. What'd you get, Hannah?
1.20.
1.20?
Yeah.
Okay. I'll just do it. I think that's about right. And we're looking for what, length? And they're measuring length in meters, so about 1.20 meters. But now let's see part B. A clockmaker needs a pendulum to complete 120 back and forth swings in 1 minute. The nearest hundredth of a meter, how long should it be? Okay, so we're looking for length again. We want to solve for L, but when it comes for time, T is supposed to be seconds for one back and forth swing. Now we're talking about 120 back and forth swings. So we need a time. We need it to be a time. So we need seconds per swing. In order for this to be a time, I need to have seconds on top. How many seconds are there in 1 minute?
60.
60. How many seconds does it take for one swing? No, 0.5. And now let's do the same thing. 0.5 is equal to 2 pi square root of L over 9.8. The steps are going to be the same. First off, you divide by 2 pi. You don't have to actually try to simplify it, but I will because I'm cooler than you are. 0.5 over pi is equal to square root of L over 9.8. John, what do you want to do next? Huh? What do you want to do next? Well, we have it right now. Yeah, square both sides. I believe that gives you 0.0625 over L pi squared is L over 9.8. Then, yeah, multiply by the 9.8. So, Julian, don't worry. Keep your calculator safe. Hannah's here. What is 9.8 times 0.0625 divided by pi squared? Here, I'll help you out. I did it last year. And so, I hope you can handle this. That what you got to do? Homework by Sunday night.
Will we get like easy or will we get like easier ones?
You think those are hard?
Kinda.
Nah, or if you think those are hard, then I thought they were too easy.